Okay. Entertaining, but no. Here we go. My question to you is the following. Where did the dHdt come from? No. Half right. The rate of the height. Look in the problem. Look in the words. Where did dHdt come from? The rate of the height, aka how fast the height was changing. Wait a minute. Why is that number a negative? That makes no sense. Oh. What's going on to the water in the tank? Emptying. So what's happening to H? Decreasing. So doesn't it make sense that the rate of change is a negative because the height is going down? Where did drdt come from? Rate of the radius. Rate derivative. Derivative rate. Instantaneous rate. Oh! Why is the t there? Because this is all with respect to time. It's like a dy dx, but who's the y? Height. Who's the x? T. Oh! dy dx, but dh dt. This one. It's like dy dx, but y is the r, and x is the t. So not, well, it's like dy dx, but it's dr dt. Do the units make sense as far as a change in feet per change in minute? Because feet is measuring? No. Feet is measuring height. And feet is measuring, and we need these to match. Do you think we might have a little bit of dimensional analysis in building bridges if they don't match? Okay, but we can do that. We've taken chem, right? Does this make sense that it's per minute? And if one of them was per hour or per second, we would have to once again build bridges because we have to make them match. Okay. Why is there a dv dt there? Do you see it in the words, though? Look at the yellow. What is the question? What is? They don't know it with a little question mark. It's what you're supposed to be finding, right? What is the rate of change in the ddt? When? What's another way of saying when? Such that the radius r is 1 foot and the height is 2 feet. Pause. These, why am I circling them in blue? And what do we do to clues? Disregard them until it's time, right? Here's the situation. Water in a tank spilling out. What's happening as the water is spilling? The radius is changing, decreasing, right, with the water level in the tank. The tank is staying the same size, but the water, which conforms to the tank, that'd be physics for us to actually talk about why, but it does. The radius is decreasing, the height is decreasing, the volume is decreasing, but they're all decreasing at different rates. They're different measurements. I know that might be weird in your mind because it's one the water is leaking, but all these different measurements are changing at different rates. They're related. Oh, they're related because there's a volume formula of a cone, 1/3 pi r squared h. They're related. No, wait a minute. Hold on. There are no rates yet. Isn't that just a volume equals 1/3 pi times a radius squared times a height? Plug in 1 and 1 and 1 and you have an answer. How do I get motion? How do I get movement? How do I get rates? Take the derivative. So here's how we finish the problem. Ready, set, notes open, go. Take ddt. But we need to have a formula first. Sometimes they give you the formula, but more often than not, it's a formula that you should know from geometry. But the good thing is in your book, has anybody ever opened the front cover and seen, okay, well, those aren't the formulas that we want, even though they're important. Geometry. And don't you also have a thing called a phone? And most of you, your phones have some sort of capability. If nothing else, ask Siri, what's the volume of a, or just type it in. Maybe she'll know it. And if she doesn't, she'll go search it on Wolfram and you'll be fine. Okay. Take a derivative of what? Of that. Now, pause. How many rule are we going to have to use? Implicit differentiation. Okay, fine. All right. If you're scared every time you hear, Good for you. Or you're like, this is going to build character because I'm going to keep on persevering through. Okay, here we go. Take the derivative of v. And of 1/3 pi r squared h. Just because you're scared of something doesn't mean you should quit it. Oh, life lesson. Doesn't mean you have to keep going, but dv dt is equal to, isn't 1/3 just a constant? Isn't pi just a constant? Uh-oh. R squared's a variable. H is a variable. Since it's not plus, constant multiple, they're just going to chill. Let's go tackle. Couldn't you guys have put them in together with that, though, if you really wanted to? Yeah, that's fine. There's constants. You could have put them in. You could have put them in, but you didn't need to. You can just leave the constants out. You guys going to do your second? D first? What's the derivative of r squared? 2r. What did we see yesterday? Whenever you take the derivative of a variable that doesn't match, what do you always have left over? What do you always have left over? So what's left over? 2r times r prime. Pause. Does that make sense? Yeah. Yeah. Just like the y, because y prime. Remember, x prime is dx dx, no big deal. Y prime is dy dx, oh, we need it. R prime is dr dt, oh, we need it. Hold on. Plus first, d second. What's the derivative of h? 1 times dh dt. Good. Oh, man, we have so many different rates. I think we're going to be in some awfully big trouble. Wait, don't we have something for that? Don't we have something for that? Don't we have something for that and for that? Oh, my goodness. Let's just plug it in. Now, hold on, pause. Just giving you a future perspective. What if you were to get somewhere right here and something wasn't given to you? Maybe, but actually, Nick, that's going to happen. And whenever that happens, no, it's okay. Whenever that happens, there's more than you thought there was. No, there's more than you thought there was. There's either like a hidden formula that you didn't realize or a hidden ratio that you can use that you didn't notice or pull out. Or there's like another equation you could have taken the derivative of and actually related or substituted. If there's ever something missing, it's because there's more to consider up here. You missed something. But in this one, yeah, there's more clues that you didn't realize. And it's okay, because if you didn't find them the first time, it could be that it's a little bit hidden. You kind of have to dig a little deeper, or you didn't know to be looking for it until you realized you needed it. Right? That happens in life sometimes. You try to prepare as much as possible, and then something random happens. You're like, no, I needed to think about that. You're like, okay, well, I'll face the problem when it comes. So that's okay. If you get down here and something's missing, don't freak out. Number one, make sure everything makes sense. Make sure your derivatives are right, etc., that the relationship, the formula that you use is actually applicable to the problem at hand. But if you ever are like, something extra is missing. No. Take a breath. Something new. Go back and look. There's something else to consider, okay? Okay. So just because you write this down doesn't mean that that's always all that you need. Sometimes you need more, but you won't know until down here. But for right now, aren't we good? Let's just plug and chug. We're trying to find, according to our question, we're trying to find dv dt such that, is it time to plug in our clues? Oh, yeah, it is. Why? Because this equation of the derivative relates the rates. Hence the name. So let's go ahead and plug in. H is 2, R is 1, dr dt is negative 0.1, r squared is just going to be 1 times 1 is just 1 times dh dt is negative 0.2. If this is a long answer, couldn't you box it and be done? Yes, except you'd miss a point. Does anybody know why? You could box it and be done, and the number is perfect. Yeah, you're going to miss a point, though, because of units. Now, you could plug this in your calculator if it was a calculator problem. But you could technically leave it if it was a long answer. If you're trying to make it match in the back of the book, you guys know what to do. Like, make it the nice answer so you know whether or not you're right. But for right now, just because we're not going to take time for you guys to grab out your calculators, etc., or for us to think about decimals, blah, blah, blah. This is not a correct stick-it-to-the-man answer until there are units. Remember how we said feet make sense, height, minutes make sense, time, feet make sense, minutes make sense, and they match up, so no dimensional analysis is necessary? What would make sense if we need volume and time? What cubed? Feet cubed per minute. Dun, 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 dun. And if you had kept the units in all along, check it out. Your R is squared, so feet per minute is feet per minute squared. Height is going to be feet per minute, so that'd be feet cubed per minute cubed. And then in the midst of all of this, as you're multiplying by different quantities, your time would end up reducing away, etc. And you would get, if you had kept your units in and you simplified them, you would get feet cubed per minute. But we're just going to kind of cheat and come to the end and be like, yay, but careful. If you're not actually putting the units in and actually making sure they all work out, you need to make sure dimensional analysis that everything matches up to begin with, or else you're going to be in trouble. Okay? So, here's the long story short that I need you guys to write down. Sorry, Mike, go ahead.
How did you get the units again? Sorry,
Let me come back to that. I'm going to explain it once we write this page, because here's what I'm going to write down. As you guys do the steps, there's a yellow box because it's important. Let me actually not make it yellow, because you guys are so used to yellow boxes being forever cards. And not that this couldn't be a forever card. Like, it is an important piece of data, and every year I'm like, should I make it a forever card? Should I not? I don't necessarily need you to have this memorized. Like, I just don't necessarily need you to make it memorized. Some of you might want to kind of squish it in. Careful using a card, though, because we kind of use them all. But you might want to squish it in somewhere like related rates, like a quick little hint or something, so that you will see it when you do your forevers. But I don't want you to memorize the steps. I want you to practice, practice, practice to where you just know what to do when you see it. But the step is to figure out what's my given and what I find, which is kind of technically any word problem ever, right? So I don't need you to memorize that. I just need you to know any word problem ever. What's your given stuff? Your find stuff. And that's what I'm making you guys practice every time I make you write the directions in the problem down. Because you're reading it and you're being lazy, which is fine. Not wanting to write the paragraph, okay. Take the words, express it as math. That's what math was built to do, was to summarize and to model. Situations, scenarios, and in our case is word problems. Write an equation relating the variables. I'm going to put usually geometric. Area, volume, distance, Pythagorean theorem. We're talking about actual quantities moving in relationship to each other. Usually it's based on some sort of dimension, area, volume, length. Ratios of proportion, ratios of similar shape, or dimensions of similar shapes are proportional. I don't know, there's all kinds of different things to use. Use chain rule and implicit differentiation to find the derivative with time. We did chain rule and implicit at the very beginning of notes, right? d dt of a is dA dt. d dt of a equals pi squared. We have to think through how to do that. Substitute all known variables. And if something's missing, look again. What am I saying? There's more to consider. Don't freak out. It's all right. There's more to consider. You missed some sort of clue, and that's okay. We all do. We all will. Or you don't know you need it until you get there, and you're like, oh, okay, let me go back and rethink it through. Let me go back and rethink it through. I need you guys to not stress out if something goes missing. I just need you to take a breath and be like, okay, let's dig a little deeper. Let's be a bit more like Sherlock. Maybe he gets all the clues the first time, but we won't. That's all right. Good show, not enough episodes. Okay. Yeah. But then there were like huge random year-long breaks, 2 year-long breaks between, I don't know. It's because the writer was distracted writing for something else. And anyway. Still a good show. A little intense sometimes. With respect to time, quick reminders. We're taking DDT. If you don't know what we're talking about, BBC Sherlock. Okay. DDT. Multiple rates of change. Multiple rates of change. You very possibly will have like a DADT and a DRDT. Well, I'm not even going to do that. Here's what I'm going to do. You ready? Rate of change of box is D box DT with units of box over units of T. Multiple rate of change. Every rate of change, whenever you read rate of change, you can always say the rate of change of box. Oh, sweet. D box dt equals rate of change of volume. dB dt equals rate of change of hypotenuse. dc dt or dz dt equals rate of change of the angle. d theta dt equals whatever it is. The rate of change of box is d box t. At the end of the day, your units need to be units of box over units of t. So if it's dv dt, it's units cubed, whatever it is, feet, inches, meters, over, let's say time is hours. Sweet. If they give you hours 1 second and they give you minutes the next, you better make them match, otherwise you'll be in trouble. If they tell you what units they want, you better make sure you get into those units before you do all the solving. Non-changing quantities are constant, and their rate will always be 0. Now here's the struggle. Was anything constant in our example of the water in the conical tank that was leaking? Was anything constant? The actual container. The container was constant. But were we dealing with the container at all? No. What were we dealing with? The water that was conforming, the conical shape of the water inside the tank. And the water that was leaking, was anything staying constant? The volume? No. It's getting smaller. The radius? No. It's getting smaller. The height? No. It's getting smaller. Was anything constant? No. So was anything's rate 0? No. Rate refers to that's in green because that's review. Instantaneous rate. Okay. Refers to the derivative. Here's a quick hint or a quick clue about constants. If something is ever constant for the entire problem, only constants can get plugged. I say disregard the clues. The only time you can plug a clue in early, the only time you can plug a clue in early is if the quantity is staying constant the whole time through all the motion. That's the only time. Only time. But if you forget and you don't realize, you'll get down to something like over here. And let's say, which this example doesn't really make sense, but let's just say for some other example, for some reason the R is not changing. Everything else is, but the R isn't. I know it doesn't make sense in this example. But let's just say the R wasn't changing. And let's just say we were missing drdt, because they wouldn't tell us what drdt was if it was a constant. And you would be like, drdt is missing. I don't know what to, and then if you actually thought through the motion, oh, it wasn't changing. R stays the same. Can anyone think of what shape the container would need to be where R would not change, even though H was? A cylinder. Yeah. The water level of a cylinder. The height changes, the volume changes, but what wouldn't? The radius stays the same the whole time, right? So they wouldn't tell you what drdt was. Why? Because you need to put it together. Oh, the R isn't changing. If the R isn't changing and you didn't think about it earlier, if the R wasn't changing, you could have plugged him in at the very beginning and been like, oh, he's constant the whole time. But if you don't realize it, down here you get dr dt and you're like, oh, it's not changing. So dr dt is 0, or would have been 0. If this was a cylinder, dr dt would be 0. Does that kind of make sense? So maybe you catch it early and you make your life a little bit easier, or maybe you catch it later and you're like, oh, I should have thought of that. Oh, well, dr dt is 0. Move on. Okay? Michael, coming back to your question, you were asking why feet cubed per minute. So think d box, dt, units of volume. I knew they were feet. Everything matched up. Feet, so feet cubed. Oh, this is such a struggle, and it's only period 1. Okay, it's okay. I've been able just to keep talking when it does that. Guys, you ready? You don't have to write these down. If you want to take a picture of them, you can. But if it says something like the velocity, oh, Lord, give me patience. The velocity of a car after traveling for 1 hour is 50 miles per hour. We know that we could just say v of t is equal to 50, but another way of saying it is the rate of change of position with respect to time, dx dt, is 50 miles per hour. Water is being pumped into a swimming pool at a rate of, wait, they didn't tell me who the rate is of. I mean, they're telling me the number. Why are they saying volume? How was I supposed to figure that out from the wording? Water is being pumped in. Isn't that adding to the 3-dimensional volume? Does that make sense? It's adding to the 3-dimensional volume. So how fast? Oh, guys, look, and it's cubic meters. Oh, duh. Volume, time, ha, dv dt. They're not always going to say the nice little rate of volume, but you have to be able to read it in the problem. A gear is revolving at a rate of 25 revolutions per minute. Revolutions? Oh, they give me a hint. Maybe I'm supposed to use that? Dimensional analysis. This one's weird. Because they say d theta dt. Is a revolution a theta? No, it's 2 pi. Oh. So I would need to change on this one 25 revolutions per minute to get d theta dt, because we're going to ask something later in the problem about the rate of change of the angle probably. Or you're going to have an angle in your formula like tangent of theta equals y over x or something like that. This has to do with angles. That's true, but revolution is not a measurement of an angle. So I could say 1 revolution is how many radians? Ah, radians measure angles. So I can take the clue of a revolution, but a revolution is 2 pi, oh, radians per minute. Got it. That's d theta dt. A revolution doesn't measure an angle. It just has to do with it. And so that's like a dimensional analysis sissy thing. Anyway. Building a bridge to get rid of what I don't want. Population of bacteria is increasing at, well, bacteria, I don't know, what's it, volume, area? Nah, just name bacteria X and be like, whatever, dx dt. And what's it measured in? Bacteria per hour. Okay, fine. You could say B for bacteria, P for population, I don't care. D box, just this guy. His rate, okay, whatever, dx dt. So it doesn't always go back to geometry, just very often it does. Okay, don't be scared. Oh, there's not even any words. We got this, don't we? It's just an implicit differentiation. Check it out. dx equals -5. Find dy dt. What? There aren't any dx dt's or dy dt's yet. What can you guys do with any equation? Derive it. So go. Huh? So far. Just wait till second semester then. How'd I get that? I just derived it, ddt both sides. Do I have enough clues? Yeah. Or, worst comes to worst, plug in what you know, and then see what you're missing. Plug in what you know, and then see what you're missing. Dx dt's become -5. dy dt's? Oh, I don't know them. Okay. Oh. All the x's become 3. All the y's become 1. Should you be able to solve for dy dt? Oh, yeah. He's the only guy missing. Let's see. I'm going to have 2 times negative 5 minus 2 times 3 times negative 5, all divided by, that's going to be 2 times 1 minus 4. What am I modeling for you? On long answers, do you have to simplify? No. Wait, your units. Yeah, they didn't tell me anything. Technically, I could say units of y over units of t. I could say that, I suppose. They didn't give me units, though. That's all right. No feet, no inches, no meters, no seconds, no hours, no... who knows? Now, if you're trying to make it match, though, what should you probably end up doing? Yeah, making this negative 10, adding 30, which would be, what, 20, and 20 over negative 2. Anybody else get negative 10? To make it match. What do you do with odds in your homework? Make it match. You have to practice multiple choice. What do you do with evens? Get it right. Right? And then come to class and we'll make it work, or we'll check it out. I'm going to put in equals real fast. That looks really confusing. Words. Now, I'm going to show you something really quick, okay? This is one way of setting up a related rates problem. I'm not saying it's perfect. I'm not saying it's gorgeous. I'm just saying it's one way. I want you guys to see if my analysis makes sense as to what I plugged in where. The given, the find, the picture, the relationships. Now, there's some work that's missing, definitely. I didn't actually show how I took the derivative. And I haven't actually gotten to an answer. But I want you to check out the words and see if this makes sense. And if so, get down the given and the find and the picture and the relationship and be ready for us to do the math to show where to go from there. A spherical balloon is inflated so that its volume is increasing. They didn't have to say at the rate. Increasing means moving, changing. At the rate of 3 feet cubed per minute. How fast is the diameter of the balloon increasing when the radius is 1 foot? This is one way to set up related rates every single time. What's your given? What's your find? Disregard the clue till the end if it's moving and changing. Picture? I don't know. It's a sphere. Has an R. That's about it. Related quantities? Geometry. I know volume of a sphere, or I could find it. Where'd this clue come from? Why this clue? Because what did they ask for? Diameter. But what's the form? Radius. Wait, I mean, I get it. We want dv dt and dd dt. Pause. Any questions on the given and the find? Are we okay? The balloon is changing so its volume with respect to time, dv dt. They asked for how fast the diameter, so dd dt. They said r equals 1. That's my clue to ignore until it's time. That's just geometry. That's just geometry. In your brain, does it make sense? This is a nice formula if it's true. Isn't this nice? We can plug in that. We can plug in that. We want to find that. But How on earth did this come about? Because if you take the derivative of r, what do you get? Not d dt, you get... Question, cool kids. What would have happened if you had derived? Good. dv over dt equals, bring down the 3's cancel. So it would be 4 over 3 pi, but the 3 comes down. So 4 pi, is that okay? Then what? Times, yeah, sorry, I just couldn't hear. R squared times dr dt. Is that right? Perfectly right. Why is it not good enough? Because I don't want dr dt. Who do I want? Okay, so don't be scared. Take a breath. There was another clue. What was the other clue? Oh, diameter, radius. There's a relationship. Oh, that's the other clue. Aw, but I want d dt and I have dr dt. Oh, couldn't we take d dt of this guy too? What would happen if we take d dt of that guy? d dt is equal to 2 dr dt. Oh. So I can plug this guy. Ah! Look at that. I can just go ahead and multiply this guy by a half, divide by 2, and can't I do a quick little substitution? There was another clue, diameter, and that's just from geometry. Diameter is 2 times the radius. Okay, take his derivative. I'm missing, but if I take his derivative, I'm going to have a d dt and a dr dt related, so I can substitute. Ah! And so when I plug in a 1/2, 4 over 2 is just 2, the pi and the r and the squared and a d dt, and I am good to plug and chug. Do I only have to take the derivative of the original equation that talks about the volume guy? No. There's another relationship. Take his derivative too. Now, there was another way to do the problem. The other way to do the problem was to think ahead and say, ugh, dv dt's and dr dt's, that doesn't work so good. The other way is you could have actually gotten rid of the r before the derivative. And you actually could have done a substitution before the derivative. The only problem then is you would have had a dv dt, you would have had a dd dt, but then you would have had a d. And you're like, oh, well, what's a d? Oh, you would have had to come up here and been like, oh, if r is 1, d is 2. You would have had to make a jump there. So either way you go, whether you go here, derivative, who's dr dt? Oh, no. And then, okay, all right, I know who he is. I can plug in. If you go this way, I don't want dr dt. Okay, fine, d dt. Oh, no, who's d? Okay, all right. D is double the r, no big deal. Either way would have been fine. Either way would have worked. Either substituting first, seeing that you don't want a dr dt, or just going for it and realizing, oh, stink. Okay, fine. Haha, take his derivative. I can plug in. So either you plug in the derivatives or you plug in the originals. Either way, you have to go one just a little. To get your final answer, you would plug and chug. And to plug and chug, we know 3 dv dt is equal to 2 pi r squared, which is 1 squared, times d dt. If you had put in all your units, a feet cubed divided by a feet squared would end up with a foot per minute or feet per minute. And you would end up with 3 over 2 pi. Does it make sense? Does it make sense? Now that's fun. Maybe it gets to be more fun. Read the words. See if translating the math makes sense. Read the words. See if translating the math makes sense. A 13-foot ladder is leaning against a wall. If the top of the ladder slips down the wall at a rate of, wherever it is. There we go. 2 feet per second. How fast will the foot be moving away from the wall when the top is 5 feet above the ground? We're talking about stuff on the ground and stuff on the wall? Okay, fine. X and Y. Who do you think I mean by Z? Yeah, the hypotenuse. Why is dy dt negative? Decreasing. Good. The ladder's slipping down the wall. Y is decreasing. So when it says down, I need to connect negative. Oh, okay. When it says down, I need to connect a negative. How fast will the foot be moving away from the wall? You have to think about, well, you get to label who's who. Go ahead and use him in your differentials over here. So down the wall, well, that's y changing. Okay, dy dt. Decreasing, negative. How fast? Slipping out. That's x. X dt. What's my such that? The top is 5 feet above the ground. That's when y is 5. What relates a right triangle? Well, all sorts of stuff does. I could be using trig, but trig uses angles, and they didn't talk about an angle, so forget that. But Pythagorean, they're talking about sides. We have two options. Anybody have an idea as to how on earth this becomes 0 eventually? What's constant? The ladder. As it slips, what's not changing? The ladder. So actually, we can do one of two things. We could just say, oh, this is 13 squared. Why? Because the ladder is always 13. This is not changing, but the ladder is staying 13. That's a constant the whole time, like the cylinder radius. And then you can say, oh, we'll just go straight there. But if you didn't realize that, you would have just gone deriving, being like, okay, whatever, and you didn't really think about the clues and how there's no z. Or dz dt, you would have gotten 2x dx dt plus 2y dy dt equals 2z dz dt. And then you're like, well, I don't have anything. Well, you do have a dy dt. You need to find the dx dt. Who's dz dt and who's x and z? Oh, wait a minute, the ladder's 13. Oh, the ladder's not changing. Oh, that's 0. But then we still have, because don't we need to go ahead and plug in an x? The dx dt is okay. I'm not supposed to know him. Plug in the y. The dy dt we know is -2. Hold on. The dy dt is -2. How do I find x? Don't. Take a breath. Go back. And make a triangle and say, wait a minute. If the ladder's 13 and y is 5, oh my goodness. Should I be able to solve for that next side? It's just Pythagorean. Guess what x ends up being? Dun, 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 dun. Move it around, you're done. Okay, this homework is not due Monday. Pause, but listen. Oh, please heed my words. It's due Tuesday, so that where or when you get stuck and you can't push through, you can come to class on Monday and see harder examples and be prepared to turn it in Tuesday morning. You got it? But if you ignore this homework this weekend, oh, buddy. The homework and the test is going to be brutal because you're going to get way. That makes sense? Get into homework, test it out. Period 6 might get a little further. I will record their video just in case they do. Bye, guys. You can do it. You can do it.